So I want to take a moment to talk about scientific notation. So first off, why do we need scientific notation? So we need it because when we deal with very large or very small numbers, they get to be cumbersome. So for example, let's take a mole. Mole. A mole is 6.022 times 10 to the 23rd power. So it's very cumbersome to write this whole thing out. So 6022, and then we move 23 digits over decimal point, right? It's very cumbersome to write, and it's very cumbersome to do math with and deal with. So we use scientific notation to simplify it. So in this unit, we're going to talk about decimal notation, exponential notation, and scientific notation. So for decimal notation, this is going to be the notation that you're used to, so 6.2 or 5,000 or maybe 450.223, right? You guys are familiar with this? Exponential notation, so what's an exponent? So it's just a number raised to another number. So for example, we have 3 to the power of 2, that would just be 3 times 3. Or 2 to the power of 5, that would just be 2 times 2 times 2 times 2 times 2. Or let's say 10 to the power of 3, that would be 10 times 10 times 10. Or maybe we have another number, I don't know, 2.6 times 10 to the power of 5. Right? So are these all exponential notation? Yeah, because we all have exponents, 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 exponents. So now scientific notation, that's a specific type of exponential notation. So that is, we're going to have a number at the front, so that's going to be the coefficient, so 2.1. And then we're going to have an exponent, so an exponent of 10, base 10. So let's say 5, right? So here, this would be the coefficient, and this would be the exponent, E-X-P-O-T. Alright, so we need two parts, coefficient and exponent. So for the coefficient, that must be less than 10, so less than 10, and the first number has to be non-zero. So first number must be non-zero. So what does that mean? The first number cannot be 0, so you can't have a number like 0.1 times 10 to the third. This would not be scientific notation. This would just be regular exponential notation. So what about if we had 2.3 times 8 to the third? So that's the second part. The exponent must have a base of 10. So this would not be scientific notation. This would not be scientific notation. But if we have a number like 2.3 times 10 to the third, this would be scientific notation. The decimal point is in between the first number and the second number, and this first number cannot be 0. And we have the exponent, and the base has to be 10. Alright? So for example, 2.9 times 10 to the fifth. Is that exponential notation? Yes. It's also scientific notation. So it's exponential notation because we have that exponent. Scientific notation because we have the exponent, base of 10, and the decimal point is in between the first and second number, and the first number is not a 0. What about 0.23 times 10 to the fifth? Is that exponential notation? Yeah, because we have that exponent. Is it scientific notation? No, because the first number is in between a 0 and a 2. And remember, the first number cannot be 0, so that is not it. What about, let's say, 3.9 times 5 to the second power? Is that exponential notation? No. The coefficient's right, so the decimal point is in between the first number and the second number, and the first number is not a 0. There's an exponent there, but the base is a 5. It should be a 10.